Great. Right, so first up we have one.
Thank you, Kat. Good afternoon, everybody. Glenn Goldstein, Texas Section Treasurer and CECon 2023 Sponsorship Chair. Hopefully you've heard and registered and sponsored and exhibited and done all of that already, but if you haven't, please consider attending CECon. We have 3 months until the big events, and we have a great lineup, tons of speakers, tons of industry personnel. We've got fun events going on. I put a flyer for those of us in the room today. Please take this back to your office, spread the word, and we're looking forward to seeing you in September. Thank you very much to the almost 40 sponsors and exhibitors who have come out and are getting ready for CECon. If you haven't and you are interested in sponsoring, exhibiting, interested in any information whatsoever, track me down, go online. Please, we're looking forward to having a great event and we need your support. Thanks a lot.
Great, well, I saw it done, so next up, you have one.
Hi, I'm Glenn Smith. I'm on the board for next year as the vice president. We are still looking for some people to join our board. So if you have any friends or younger coworkers that are possibly 35 and younger, or young at heart, please let me or Catherine or anybody else know. We have several positions open and we'd love to get you plugged in. And we want to thank everybody that came out to our creek cleanup this past week, where we have adopted the creek portion of Shoal Creek from 12th Street to 15th Street. So thank you for joining us there.
Austin, did you want to? But yeah, what do you sneak on in here and I'll do the rest?
Hello, Austin Mesterly, Section Director. 2 things to note. We just started elections for the Texas Section Board Committee chairs. We have a few Austin branch folks that are involved with that. I think that's about all the new election rules. So make sure you're taking advantage of those. And then the second one is the infrastructure report card. I believe many of y'all are aware the infrastructure report card has started on the national level as well as the state level. We're kicking off the state level recruitment basically this week. So if you're interested or have any questions about that, I will be one of the co-chairs for this release in 2025. So please let me know.
Thank you. So next up, we have the Structural Engineering Institute. SEI typically has meetings during the fall and spring every other month. And they also do periodic technical tours, including tour of the Q2 Stadium last fall. And they're looking for the return of their structural engineering talks this summer. I haven't had the date yet, but these are typically more in-depth talks that are kind of similar to TED Talks that focus on the structural engineering side of our engineering world. If you also look at our handbooks, we have a QR code on the back of that that y'all have that will take you to a couple of these links. And we also have the Linktree link there. Okay, next up we have EWRI. We recently had our EWRI continued education workshop, and it was a success. We had 170 15 speakers, and everyone that attended got 6 PDHs. The money from this event is going to go towards building rain gardens, our community, and our schools. And it will increase the amount of money that they can give to our student scholarships against next year. So meetings for EWR are postponed until fall 2023, but they are looking for volunteers and leaders within EWRI. And you can go to their open house in October or check out their website. You can also email EWRI.communications@austinamsp.org to reach out if you're interested in that. Last announcement, please follow us on social media. You can find us on that Linktree or any of these resources up here. All right, next up, I would like to invite up our meeting sponsor, Halff. And we have Burrito today.
My name is Marie Tamoya, and I'm here in representation of Halff. We're really excited to be this month's sponsor. To give you a little bit about Halff, we are an employee-owned firm, full-service engineering and architectural, with this one mission to improve lives and communities by turning ideas into a reality. And we do this in several different ways. First and foremost, we do have a people-first culture, trying to give training and resources so that they can be the best professionals they can be. And in turn, this also helps us generate smart solutions and innovative spaces for our clients and communities to really support the residents who use the space so they can be safe and enjoy it too. Last but not least, our non-professional services. We do have an internal nonprofit organization called Halff Community Initiative. This is a really great opportunity to allow our employees to donate and also volunteer in local communities through where they serve and work. This is a general graphic of our geographic footprint. We are about 1,400 employees in 5 different states. We have 31 offices. Most recently this year, we added an office in Lubbock. So for those Red Raiders out there, I'm a Red Raider, so I was excited to see that. And then we also added a couple in Florida. Our Richardson office is our headquarters. And then furthermore, in the last couple of years, we've been expanding in Austin. So we now have a North Austin and a South Austin office. All these offices really support our solutions. Halff is organized in 6 different solutions groups: energy, environmental, mobility, placemaking, technology, and water. To give you guys a little overview of some projects we are a part of here in the general area. Right picture is the Bastrop State Park Dam. This dam actually failed in the 2015 storm events that also Austin experienced as well. So Halff was a part of the multiple different ways. We did the H&H analysis, the design work. We also did survey, environmental, and also engaged our landscape architecture group to help with some of the park features. So that was a fun project to be able to collaborate internally, and the dam finished construction this year. So we're excited that it's fully functioning again. In the center there, this was a big project last year. It was in East Austin. The 2 center pictures on the bottom, there was a culvert in a residential area. It outfalls into Lady Bird Lake. And the culvert was experiencing some leakage, so it was impacting the subsurface, and the residential area was having some failure in their roadway service. So we were able to excavate, fix, and repair the culvert. And then in the meantime, we also, once again, was able to engage other facets by replacing the stormwater, water, and wastewater utilities. So that residential area is now fully repaved, and also the subsurface is mitigated. Last but not least, we are also very involved in a lot of floodplain modeling and mapping. We've been longstanding partners with Texas Water Development Board and FEMA. On the screen here, I have the City of Austin as well. The City of Austin this year just kicked off their Atlas 14 studies, really remapping the city, all the floodplains, and identifying flood risk. And then with that, after we identify risk, we can also look into long-term mitigation solutions. So once again, we are very excited to be sponsors today. And I did want to give a quick shout out and thanks to all the volunteers. I know it's a lot of hard work, but this year was a success. So I'm excited that we're continuing to grow. So thank you.
All right, up next, I think we're all excited here as speakers today. Expanding utility access to the South-Southern community north of Austin. We know that we have a lot of people living in Austin. I think this is a very important topic to see how we can expand our utilities, our infrastructure is growing. So first up, I'd like to introduce Aaron Archer, PE, Vice President of Walker Partners. Aaron is Vice President of Walker Partners in Austin, and he has 20 years of experience in water treatment, pumping, and conveyance projects. Aaron holds a Bachelor's of Science in Civil Engineering from the University of Texas and a Master's in Environmental Engineering from the University of North Carolina. He's been leading design development of the BCRUA Phase 2 raw water delivery system for the last 15 years. And next up, I would like to introduce Karen Bondy. Karen is the General Manager of the Brushy Regional Utility Authority and has 36 years of water industry veteran experience, working nearly 20 years with the Lower Colorado River Authority prior to joining the BCRUA. As BCRUA's General Manager, she oversees an expansion of this project we're talking about today, while completing final design and construction of the project as well. Aaron and Karen, can you come up? And we're really looking forward to what you guys have to say.
Just do the Aaron too. Well, good afternoon, everybody. It's nice to see so many faces. I'm Karen Bondy, the General Manager of Brushy Creek Regional Utility Authority. I am a civil engineer. I have my undergrad from UT Austin and then my master's in environmental engineering from UT as well. The chapter meeting after I graduated from college, there were maybe 12 people, and they're all these old guys around a table. And I came and sat in one of the chairs, and they never even looked at me or said anything to me, and they all just kind of talked among themselves, and I never went back. But I'm really glad to see what you all are doing here, and all the great things I heard about that you were doing today. So let me get the presentation up. Next slide. Okay, a little AV help here.
Oh, sure, intro.
Hit the space bar. Space bar. I like it. We're good. Aaron and I are going to tag team here. I'll talk about this kind of setup, what it's all about, all the partners in it, some of the challenges and why it was created. And Aaron's going to talk to you about our really cool project, the deep water intake. BCRUA is a partnership of Cedar Park, Leander, and Round Rock. Not familiar with the area, so just northwest of Austin, the cities, well, Round Rock's north, and then going west over to Lake Travis area are the three cities. And there have been a lot of studies on how to get water to these three vastly growing cities. I mean, you should understand, fastest growing cities in the United States. And so they were all looking at a long-term water supply. And there was a study done in the late 80s by the Texas Water Development Board called the Trans-Texas Water Supply Study. And that identified options for water. And sort of going off of that, there were some other studies done by the individual cities. Well, I have brought from the relics of the archives a study that I actually did. See, it's actually printed. When I was at a consulting firm that I started on when I got out of college, things I actually sealed, but it is equivalent cost boundary study for Williamson County water supply. And basically, are maybe closer to Lake Travis than they are to Lake Stillhouse Hollow, which is another water supply from the north of Brazos River Authority. Got our experts here. It was trying to figure out, well, these three cities, they're there's a great deal of elevation, a lot of lift to take water to where they are, basically on the watershed boundary. So this study looked at, in terms of costs, sizing pumps, pipe, power costs. Where is the line where it would be cost the same to pump water from Lake Travis on up north compared to bringing water south from Stillhouse Hollow, Lake Georgetown, which was fairly flat. And so that's actually just north, about halfway between Round Rock and Georgetown. So it just showed that it was more cost effective to bring water to that city particularly, and also Cedar Park and Leander from Lake Travis. It was challenging because those cities really, the way water law is in Texas, it's you can't just pump water from one basin to another without losing your water right priority. So there was some legislation passed to allow that water to be moved outside of the lower Colorado River watershed, and a lot of work went into getting to the point where some water could be delivered to Round Rock. And Leander all got together and figured out that they all needed the same thing. They needed big pumps at Lake Travis, lots of pipelines to get to their cities. And they started talking about this partnership in 2005. And it finally was created in 2007. And it really, a lot of cost estimating was done to determine that, they provide, at the time, it looked like it was going to be about $100 million of cost savings for them to work together as a partnership. And also save each city having to put in their own intake. Not a lot of places along the shore of Lake Travis to even locate this, alone how much this local community, a huge pump. So the partnership was created. This is a picture of the water treatment plant. It's right now, you can see there's 2 water treatment trains also completed, and we're working on the 4th one right now because it's a lot of demand and a lot to keep up with. So this map shows the facilities that were built. The red line is, you can see Lake Travis. The arm of Lake Travis is on, so red line is a pipeline that goes all the way to Round Rock. So all that infrastructure was built initially. It's about $130 million loan taken out from the Texas Water Development Board, and that all occurred in 2012. Water pumps, and the water phase was built. And then shortly after that, the demand's growing, then we built the next train, and then again, we're now working on the other one. Well, all along, the cities realized that floating intake on Lake Travis would not be a good long-term solution. So that's phase 2 deep water intake. But it was really planned from the very beginning. So this is a picture of the floating intake on Lake Travis, and Lake Travis hydrology, which I know some of you all do, but there was one year when Lake Travis came up over 50. So it is definitely, and there needed to be a more secure, reliable option to pump water up to the cities than this. But that's been working pretty well so far. Except for when the zebra mussels showed up. That's another story. But then on the other hand, we have vulnerability. all-time low inflow out of Lake Cannon, and you can see they all, nothing 2006. So it's been fairly but the picture on the top, 3 tiny little white dots there, those are the floating intake. Cedar Park, each other. Those will all go away once we get the deep water intake. But when the lake's high, okay, plenty of water. But look what happened in 2013 when the lake got low. Those intakes are being out of the water. In fact, Leander and Cedar Park built what they call their drought barge that could be extended further. Actually built, Aaron could probably go into this, but they built a pipeline and basically snaked it between that marina there. But so we know that even looking at the fluctuations we're seeing this year, that we needed to have intake in a much deeper location. And so those were some of the project drivers. As far as the plan right now, have been, I said, for looks like 10 years. And a lot of that was getting all the 3 cities. Interesting when you form a partnership and all those soft skills, those you need as an engineer. But when you bring 3 different parties together, of course, everybody knows that regionalization is the way to go, but it does bring all these disparate people together and with different projects. So a lot of that got worked out through the planning period so that everybody's come to agreement on how to move forward. The Water Development Board is funding this in the middle of, and they lent us probably almost dollars for this project, because it's not only the intake, also the electrical power to get there, and the expansion of the water treatment plant. So fortunately, we've been able to get good funding from the Water Development Board, and the design and land acquisition. I'm going to ask Aaron to talk a little bit more about that, but power had to be brought in from a long ways away. So we are a year into. I will tell you that the challenge, we were really for $200 million, and then the cost came in at $225 million. We had to fund the project. Then we had to go back to our contingency, because your project, we're going to need it. So there's nothing really been easy about this project, but it is a very interesting project, and it's been a great team we're working on. And I'll bring up Aaron Archer, who's been a fantastic engineer and project manager for us.
Thank you, Aaron. When I guess, Karen, when you were sealing that report, I've worked on this project a long time, but at that point, I was learning how to drive a car and getting my braces removed. So let's talk about the construction contract. The contractor is a joint venture of Thale and SAK, and we selected them through a competitive sealed proposal process where we got to make a selection based on both cost and non-cost factors, including their qualifications. Like Karen mentioned, we're almost exactly 1 year into construction. 5-year construction duration puts us close to 20%. The contract value is just shy of $225 million, and construction management services on behalf of BCRUA are being performed by Walker Partners and Freese & Nichols. So I want to drill into the project overview, the layout a little bit closer. This is a blow up of the map that Karen showed you. The ultimate capacity for phase 2 is 145 million gallons per day, which will meet the build out water requirements for Cedar Park, Round Rock, and Leander. The major project components, the way that the water flows is first up in the upper left-hand corner in the lake is a intake at a deep location. It's about 125 feet deep there when the lake is at conservation pool. Adjacent to it on shore is a maintenance building. So I'll tell you more about the purpose of it in a little bit. The blue line is an intake tunnel that conveys water by gravity back to a remotely located pump station next to Cedar Park's plant on Lime Creek Road. And then that pump station pumps water back across the lake again in another deep subsurface tunnel in the gold line, where it connects to the original phase 1 pipeline installed in 2012 and shown in red. An interesting thing about this pump station is it sends water actually to 3 different water treatment plants. We want to get off of the floating intakes in the lake right now. So it'll send 106 MGD to BCRUA's plant. It'll send about 12 MGD to Leander's plant. And the difference, or about 30 MGD, goes next door to Cedar Park's plant. And everything I just told you in about 60 seconds in real time took our team probably close to 11 years to complete. And just to give you a sense, 11 years, that's a long time. I mean, 11 years ago, I think that we were all talking about Johnny Manziel as Mr. Football. It's been a minute since we were talking about Johnny Football. 11 years ago, I had a social life. I didn't have 3 boys. A lot has really changed. But we looked at, as it turns out, 11 different sites, all kinds of different alignments for the tunnel and for the intake. And ultimately, we selected this one, which costs extra money. This was not the highest ranked alternative, but we selected this alternative, or BCRUA did, because it eliminated a lot of community impacts out there on the lake, in particular in the village of Valente, where we originally were planning to construct the pump station. So I want to start now on the main shaft. The main shaft is at the pump station site next to Cedar Park's plant. This is really the heart of the project right now for the work that has gone on for the last year and will continue for the next year and a half. This is the access shaft for all of the underground work for the tunnels going both directions. It's a 30-foot diameter shaft. It's 300 feet deep, and these are some photographs you can see from construction progress. The shaft is actually complete at this time. It was excavated by hydraulic breakers. The rock quality is really good. It's limestone with an unconfined compressive strength of about 4,000 PSI. We haven't encountered any voids or any other issues during construction. Initial support was minimal, rock bolts and shotcrete. And the final liner is a cast-in-place concrete liner. The contractor elected to do a top-down installation method for this liner, which means that as they constructed, they would excavate, set up a formwork, do a concrete placement, continue excavation, jump the formwork, and build it on their way down versus excavating the shaft and building it up from the bottom to the top. Now you have to, and I want to explain this plot too. I know it's a little bit hard to see, but the blue line is the excavation production, and the orange bars are the concrete lifts, and the y-axis is elevation, or the depth, and you have to watch really close right now. That little guy that bounced in the bottom, that's to scale. That's what it's like to stand at the bottom of the shaft. And I've been down there and you feel like a little ant looking out of a big, deep hole. They really did a good job getting into a 3-day cycle for constructing this liner, where they would excavate, jump the form, do a placement. And you can see they really picked that up after the 3rd or 4th concrete placement, working 2 10-hour shifts. Down at the bottom of the shaft, connected to the shaft, is the suction chamber. This is a large underground horseshoe-shaped chamber that the pumps take suction out of. It's about 90 feet long, 30 feet wide, and 20 feet tall. So it was constructed in 3 different headings, a top heading, and then an upper and a lower heading. by hydraulic breaker and also using a road header. In the upper right-hand corner, you can see a road header. It's basically a cutting tool on a boom that allows them to achieve that horseshoe shape. And the suction chamber at this point also has been constructed. And eventually, towards the end of the underground work, they'll come in and put in a cast-in-place concrete liner. Where the contractor is right now is construction of the transmission tunnel. And the transmission tunnel is the gold line that I had shown you previously. It's about 2,600 feet long, and it'll be constructed at a 3% slope, sloping up towards its endpoint so that any kind of water or seepage into that tunnel flows back to the main shaft for removal. At this point, this is really tight rock, so we've seen very little seepage into the tunnel, which is what we expected. It'll be constructed by an open rock tunnel boring machine. It's 11-foot diameter, and these tunnel contractors like to name their TBMs. This one is named Miss Chelsea, and this is Miss Chelsea now. She has been assembled down underground, and they have just started mining the transmission tunnel. Because of high quality rock, initial support again is fairly limited, pattern bolts and shotcrete, and we anticipate construction requiring about 3 months for them to get to the end of this tunnel. And once they get there, they arrive to what we call the Trails in Road shaft, which is a vertical shaft where the transmission pipeline, which is a welded steel pipeline that'll be placed in the tunnel, will go vertical to take us back up to grade so that we can connect to the original phase 1 raw water line. It's 130 feet deep, constructed by a blind bore construction method. And you can see the pile top rig to the right that was used to construct that blind bore. An interesting thing about this shaft location is that it did require a secant pile wall. This is the only location on the project where we had any real overburden. And so we need to do that to have support through the overburden. But also the shaft location is just about 4 feet higher than the conservation elevation of Lake Travis. And Lake Travis is really low right now, so you wouldn't guess this if you went out there. The lake is very far away from the shaft, but it is very possible that it could come up and it could end up going through the overburden and basically flooding the tunnel. So we have a secant pile wall socketed into rock, and the contractor is right now planning to take the steel pipe pieces and place them in the shaft and grout them in place. Once that steel pipe is placed in the shaft vertically, there'll be a bulkhead on top of it so that water cannot enter the shaft for the underground construction. 3 months from now, the contractor will be done mining the transmission tunnel. So they'll walk the TBM back out and they'll start construction on the intake tunnel. The intake tunnel heads the other direction, connecting the pump station to the intakes. And it's a little bit less than 9,000 feet. Again, same diameter, 11-foot diameter machine will be used to excavate it at a 0.1% grade. And if you look at the alignment here, you can see there's a number of curves in the intake tunnel alignment. And we didn't do that just to make life hard for the contractor. That was part of what we had to do for easement acquisition. And there's a lot of Balcones Canyonland Preserve out around the lake at this location. So we needed to avoid it. We were not allowed to tunnel beneath it. The final liner for the intake tunnel, because this is not pressurized, it'll be gravity flow, is going to be cast in place concrete. The contractor estimates about 9 months to complete mining of the intake tunnel. And they do anticipate having an on-site batch plant for concrete production because there'll be a lot of concrete. We did go during the design phase and acquire some easements for concrete drop shafts to facilitate getting that concrete up to the face of the cast in place operation. When all of these tunnels are done, we'll go back to the pump station and we'll start working on the pump shafts. And the pump shafts are basically vertical shafts that go from the pump station up above down to the crown of the suction chamber. There'll be 6 of them with an 8-foot OD and a 6-foot internal diameter. And we'll place pumps in those shafts to take suction out of the suction chamber for a total of 6 pumps at the suction chamber. And we'll also put 4 pumps in the main shaft. So up to 10 pumps at build out. There's also a shaft that will be constructed for the discharge pipeline to take that pipeline and run it out the transmission tunnel back across the lake. Because the contractor does have access underneath to work where they have built the suction chamber already, they'll be using something called a raised bore method, where they drill a pilot down into the underground space and then connect a cutter head, which you can see in the photograph here, and pull that back up to the surface to excavate the shaft. Now I want to move out to the lake and talk about the intake and the maintenance building. This is an architectural rendering of what it would look like at some point in 2027, with the lake being a lot fuller than it is today. The intake facilities consist of two individual riser pipes that connect the screens in the lake to the intake tunnel down below. Each riser pipe has a pair of screens. So we have 4 different elevations that BCRUA can withdraw water from Lake Travis. And the reason we do that is in the summertime in Lake Travis, a thermocline sets up. And if you're a diver and got certified in Lake Travis like I did, you've experienced the thermocline. When you get there, the temperature is significantly lower than the water above, and water quality is very poor. It has low dissolved oxygen, dissolved iron and manganese, and things that make treatment difficult. So we want to try to take water in the upper 30 or 40 feet of the water column. And because Lake Travis is a variable level lake, we need to have multiple intakes to allow for that. Both of the intake lake taps are centered on the tunnel, and they'll be comprised of 96-inch diameter, 316 stainless steel pipe. Right now, because the contractor is almost done constructing the shafts for these intakes, they'll be in short order getting this 96-inch diameter stainless steel pipe and getting it ready to float out in the lake and drop down in the holes to grout in place. These are just a couple construction photos of work out on the lake. They have a pretty significant flotilla out there completing this work. And if you're familiar with Lake Travis, you're actually pretty close to Starnes Island off the shoreline of Valente. But you can see the 2 casings that are being used to facilitate construction of the blind bore lake taps using reverse circulation drilling. So they've got basically a water treatment unit out there with them so that they can settle out spoils and then return that water and continue to use it. So let's talk about how the intake tunnel and the lake tap connection will work. The lake taps will be completed before the tunnel boring machine ever gets out there. They'll be grouted in place, and there'll be a grout plug beneath the intake riser pipes that the boring machine can mine through. So as the boring operation approaches the lake taps, they'll be doing probing and grouting. We want to make extra sure that there's no water that can make its way from the lake above into the tunnel below. They will mine beneath both of the lake taps and add some extra support as required at those locations. Eventually, they will make their connections to both of those riser pipes before they walk the TBM back out. And each of these 2 riser pipes has a pair of bulkheads on it so that we can make sure, again, that water does not enter the underground until we are ready to flood it. Okay, so the maintenance building. Well, the purpose of the maintenance building is to control invasive mussels. And we were planning on needing a maintenance building for invasive mussels before they ever showed up in the lake. Who wants to hear an interesting story about mussels? Good, that's the story I practiced. So invasive mussels, zebra mussels, which are probably not the last invasive mussel that we're going to see in Lake Travis, but they're the one that are there now. And if you've gone there and you were barefoot, you probably found out the hard way. But they showed up in the lake about 4 years ago. And 1 year after they showed up, BCRUA decided, why don't we go look at our floating intake pumps and see if any mussels have attached to it. So you can see the photograph in the upper right-hand corner. That was 1 year after detection of mussels, because there is no place that mussels would rather be than a raw water intake system. They're filter feeders and they have a constant supply of water going by them. So they can colonize and infest things very, very quickly. We have 2 chemical feed systems for the maintenance building. One is copper sulfate, which we anticipate dosing pretty much around the clock during the year. And then if we feel that we need a stronger oxidant to deal with some stubborn muscle issues, we do have sodium hypochlorite, which is liquid bleach, that we could apply as well. But we wouldn't anticipate applying sodium hypochlorite on a regular basis because it can create issues with disinfection byproducts later. These are some progress photos of work at the maintenance building. They're just kind of getting going on the maintenance building itself, but you can see the marine operation out in the lake off of the shoreline. Now jumping from the lake side over to the pump station. This is an architectural rendering of the pump station. It's a significant building. It's about 18,000 square feet. It is a very tiny site. It was formerly a portion of park property that was acquired for this purpose. And so we minimized how much land would be required for the facility. One of the most interesting aspects of design of the pump station was actually picking a pump. These are very, very deep pumps. And so early in the design process, we elected to use submersible pumps and motors. And the reasons we did that is first, it simplifies maintenance. If you have to pull one of these pumps to do maintenance on it, it would take a day or two. There's a lot of column pipe to disassemble and put back together. A vertical turbine pump with a line shaft going down the middle would take 1 to 2 weeks to pull it and another 1 to 2 weeks to put it in. It also reduces or virtually eliminates noise because the motor is down underground and underwater. And when you go by a submersible pump like this, you really can't even tell that it's operating. You kind of have to feel the discharge elbow to tell that it's even pumping. And then lastly, with long line shaft pumps, you really have to be cautious about shaft strain and vibration issues. And submersible pumps don't have that problem. We eliminate those concerns. There's actually, in this pump station, 2 separate systems, 2 separate pump stations within the one building. One will convey water to Cedar Park's plant next door. There'll be 4 pumps in that main shaft that gets repurposed as a wet well. The other 6 pumps will send water back across the lake. And we've got 3 different pump designs ranging from small motors at 550 horse up to 3,600 horsepower motors. One of the really interesting things that we got to do during design of this project is we formed a good relationship with Southern Nevada Water Authority out on Lake Mead, because they were in the process of designing and building their own deep water intake project with Lake Mead continuing to fall. They call it L3PS, which is a 1 billion gallon a day system. And it was a neat relationship because we got to go out there. They kind of rolled out the red carpet, showed us what was working and what they liked about that project and things that they thought could be improved so that we could take home some lessons learned and make some revisions on our side. We even got to see them go out and install one of their large pumps, which this pump was developed by ENR, a submersible pump manufacturer in Spain, who is also going to provide pumps on the BCRUA project. So this is an engineering drawing. I know it's kind of ugly. I just wanted you to see that there are the 6 pumps that go down and take suction out of the suction chamber, and then the 4 pumps that will be positioned in the wet well. So third-party coordination. If there's any part of the project that gave me gray hair, this was it. We had a lot of regulatory agencies that were interested in the project that we had to pull permits from. The Corps of Engineers, City of Austin and Travis County, the LCRA, a lot of work, years and years of work with the Village of Valente, Balcones Canyon Land Preserve, and TCEQ. Water Development Board, as Karen had mentioned, has been funding this project from the beginning and is funding phase 2. And then we had to acquire land rights from 202 parcels. And only a small fraction of those were really needed for the tunnels and water side of this project. Yes, you still have to get an easement for a deep subsurface tunnel. But the electric utility out there looked at this as basically a line extension request and told us that we needed to figure out the routing and obtain all the easements necessary to get dual feed overhead power to the site. So that added a lot of easements in addition to a substation expansion, all of that coming in at a price tag of about $25 million, which is not part of the construction contract. So with that, I do want to acknowledge and thank our owner team, of course, BCRUA, the 3 cities, Cedar Park, Round Rock, and Leander. Friesen Nichols, our joint venture partner with Walker Partners. And then Schnabel Engineering and K. Friesen Associate had a major role in the project. And then, of course, our contractor, the LSAK joint venture. And with that, Karen and I would be happy to answer any questions. I think we've got a few more minutes. Yes, sir.
What was it at the end you said there about that dual overhead power was the agency that will fund that?
Cardinals Electric Co-op provides power in this area.
And did y'all have to go through a NEPA process?
We didn't have to go through a full-blown NEPA process now.
But just like EA or?
Yes, just an EA. Yes, sir.
Backup power.
Backup power is off the electric grid. Generators are not really feasible at this location, but the power load we have. In the back? So we have installed a number of monitoring wells along the alignment, both in the aquifer below where residential wells would be located or domestic water supply, which is on average about 100 feet below the tunnel. And then we have dosimeters in the tunnel zone, and we've been monitoring those for years to develop some baseline data to understand if there's an impact as construction commences. We also have requirements for the contractor on monitoring seepage into the tunnel. But at this point, if anything, they're more often having to introduce water to control dust because there's almost no seepage. It's extremely tight limestone rock. Yes, sir.
What's the contractor doing in the excavated material?
That is a good question. It is a lot of material. Unfortunately, there's a quarry that is owned by Cedar Park just down the road on Lime Creek Road, the Ruby Quarry. So they've been able to bring their spoils there. Sir,
Just maybe a question. Here.
Okay. It's not correlated. We're getting SWIFT funding for this project, so there's not a direct relationship. It's been tracked in Region G for many, many years, and this is just continuing phases of the same project. They've been funding this, some of that early design work back in 2011. One more. Go ahead, Liz.
Aaron, you talked about after the tunnel, both of them are going to block the tunnel. Some discussion initially about leaving them in place versus walking back out. Is that a contractor decision or is it just no, you can't?
A little bit of both. We, in working with LCRA to obtain these, we decided that we didn't want to allow abandonment of the TBM. They finish the intake tunnel, they're not simply going to walk it back out. They may just disassemble piece by piece. That when they finish the transmission tunnel, they do tend to walk it out, which takes the time. You know.
Thank you, Aaron.
Thank you.
And can I ask for today's attendance? Total of 78. That's great, you guys. Even more than Paul had said before. All right. Well, thank you everyone for joining us today. Our next meeting will be in September. We're taking the next 2 months off, and we will be bringing in our new board at the next meeting. So, thanks.